Hey everyone, Mrs. Garcia here. Today we're looking at notes A-2, literal equations day 2. So since this is only our second video, I will give you a couple of quick reminders. So remember that your name should be in the upper right hand corner in pen, and also that your note should look just like mine in order to receive credit, with two small exceptions. Exception number 1, your name should be here and not the word name. And exception number 2, you may not use the same colors as me. In fact, you may not use colors at all. You might use pencil, and that is perfectly fine as long as your notes look just like mine, meaning you have everything written down that I have written down where I have it written down. Okay, I have this little bubble right here. You shouldn't have it down here. You shouldn't have it over here. You shouldn't have it over here. Okay, your note should look just like mine in order to receive credit. So with that being said, especially on a video like this one where I start off with I've got a whole bunch of stuff already written out for you, you should be pausing the video often, okay? So right now you should be pausing to make sure you get all this stuff down, because here's the problem. If you're rushing to write this stuff down as I'm explaining and pointing at things and going through things and talking, if you're too busy thinking about what you need to be writing next instead of actually listening and understanding, then when you get to the assignment, you're going to be very frustrated, potentially. Okay, and I don't want that. I don't want you to get to the assignment and say, I am totally lost. I'm so confused. I don't get anything, because I was so busy trying to make my notes look just like hers that I didn't even listen to her or watch her. Okay, so please make sure you pause often. That way you can actually listen and watch as I go through these examples. Okay, so let's get started. Before actually we get to the literal equation part of today, we need to refresh some concepts from Algebra 2, because these concepts we will be using in our literal equations today. So the first concept that we are going to refresh in part 1 is rationalizing the denominator. In other words, remember the word rationalize means remove the radical. So we are going to be rationalizing the denominator, so therefore removing the radical from the denominator. So another quick reminder is that if you have a radical and there's no index written, remember that the index is the little number that's somewhere, it could be up here, but sometimes more seen down here. Okay, when there's no index written, the index of 2 is implied. And that's what we'll be working with today. We'll be working with square root only. Okay, breathe a sigh of relief. No cube root or fourth root or fifth root or anything like that today. So before we start rationalizing the denominator, I have another quick reminder that if you take a square root and multiply it by itself, that it will just equal whatever's under the radical. So for example, like square root of 7 times square root of 7 would just equal 7. Square root of 13 times square root of 13 would just equal 13. Likewise, I mean, you could take any number. I know that these are both prime numbers here, but I mean, you could take square root of 20 times square root of 20 and it would equal just 20. Now, of course, that doesn't work when you have cube root and fourth root, etc. But like I said, today we're only going to be working with square root. So that reminder will help you with this. So look at number 1. On number 1, if we're asked to rationalize the denominator, remove the radical from the denominator, we're going to use this knowledge. Okay, I know that to eliminate this radical here around the square root of 3, 5 divided by square root of 3, that I can multiply by square root of 3, and then the radical will essentially be gone, yes? Okay, but in math, it's only legal to do this if you multiply this expression here by square root of 3 over square root of 3. Because remember, 7 times 1 is 7, okay? 23 times 1 is 23. My point is, when you multiply a number by 1, the number still stays the same. The value is still the same. Now, I might be changing the appearance, how it looks, okay, but I'm not changing the value of this number here when I multiply by 1. And square root of 3 over square root of 3 is like multiplying by 1. That's why it's legal. Okay, so now I'm going to have, when I multiply two fractions, remember, numerator times numerator, denominator times denominator. So 5 times square root of 3 is 5 square root of 3 over, of course, square root of 3 times square root of 3 is just 3. And then you look to see if anything can simplify. It can't. You make sure that you did what you were asked to do. Did you rationalize the denominator? Is the radical gone out of the denominator? Yes. Then you box it up because you are done. Okay, next problem. So on problem number 2, I know I'm working with variables, but the concept still stays the same. So 12x divided by square root of 2x. So again, if I want to rationalize the denominator, then I'm going to multiply by this exact same radical here, because I know that will get rid of the radical. And of course, to make it legal, I've got to multiply both the numerator and the denominator by the same thing, because anything over itself is like 1, and multiplying something by 1 is legal. Okay, so this would be, when I multiply across the numerators, 12x square root of 2x. Make sure that that radical bar completely goes all the way across and covers the x completely. Okay, over, of course, this will just become 2x. All right, and then I can simplify a bit. I can simplify the x's, and then I can simplify the 12 over 2. So 12 over 2 becomes 6. Like I said, the x's simplified out, essentially, and then I've got the square root of 2x. So nothing in the denominator now. So again, we have rationalized the denominator. We have a radical, but it's in the numerator, so that's okay. All right, so now in part 2, let's refresh a different set of concepts. So here, we're refreshing how to solve an absolute value equation. So remember in Algebra 2, if you had something like this to isolate x or get x by itself, essentially to get rid of the absolute value bars, you split this up into 2 separate equations. One where you said x equals -8, and the other one where you said x equals +8. So essentially for this, your answer would be x equals plus or minus 8. We will not separate them, we'll keep it together. So we'll say x equals plus or minus 8 here. And likewise on this problem, your answer would be, you guessed it, x equals plus or minus 13. Okay, and that brings us to, where does this come into play? Well, right here on number 3. If you had a problem like x squared equals 25, and again, you're trying to isolate the x or get the x by itself, you've got to get rid of the square here. So I'm going to rewrite the problem, because I'm going to square root both sides. Okay, and what happens when you square root x squared? Oh, be careful. Be so very careful. You get absolute value of x. Remember that whole rule from Algebra 2? When you square root x squared, your answer is x, essentially. Okay, because x times x equals x squared, so your answer is x. But when you have an even index, and the index here is 2, and an odd power on the variable that comes out, this is an odd power, it's x to the first, even index odd power means you get absolute value bars. Okay, equals, and then the square root of 25 is 5. And then of course to solve this, you would have x equals plus or minus 5. Okay, and I actually want to do one more problem that I forgot to put on here. So problem number 4, x squared equals 49, just to make sure we totally are grasping it. Okay, I'm going to rewrite the problem, so that way you can see my step of square rooting both sides. So make sure your notes look just like mine. And then, of course, the square root of x squared is absolute value of x. The square root of 49 is 7. And then to get rid of the absolute value bars, you have x equals plus or minus 7. Okay, so those are the Algebra 2 things we need to know before we get started with our 2 problems for today. So in part 3, we're finally to the literal equations. So you've got these 3 equations, one that deals with volume, one that deals with area, and then this one that deals with volume, and you're asked to find A in terms of R. So remember, this tells us what we need to find for our final answer, A in terms of R. So this equation here can only have the variable R, okay? So R is acceptable, 2 is acceptable, pi is even acceptable, okay, because it's not a variable. The variable that's not acceptable is H, okay? We can't have H in our final equation, A of R. So that means I need to find out what H is in this other equation. So I'm going to take this other equation, but instead of writing V equals, of course I'm going to plug in what I know V is. So 10 equals pi r squared H. Okay, and remember, H is what I'm going to be solving for. So I can divide both sides here at the same time by pi r squared, because remember I want h isolated, so simplify the pi's, simplify the r squareds, and I've got 10 over pi r squared equals h. So h is already isolated, that's nice. So this is the expression that h equals. It's the expression that will go into the other equation. So I'm going to get started with that. A of r equals, okay, so then I come here, and 2 is okay to write, pi is okay to write, r is okay to write, h is not okay to write. I plug in what h equals, so 10 over pi r squared. Okay, and then I keep going, plus 2 pi r squared. All those things are acceptable, okay? Remember, my final answer should only have the variable r, and it does. Well, this isn't my final answer, but it's going to only have r, right? So a of r equals, okay, we can simplify. Remember that this is over 1, okay? And we can simplify out the pi's. And we can simplify 1r with 1r here, so that'll only leave me with a single r in the denominator. So then I multiply across my numerators, so 2 times 10 is 20, over 1 times r is just r, and then plus, and I don't have to do anything with that guy, with that term. Okay, so that is your final answer for problem number 1 in literal equations day 2. Okay, let's get to problem number 2, our last problem, and the problem that you'll see why we did all that review from algebra 2. So we've got these 3 equations here, and we're asked to find a of h. Okay, so a of h, that means when I look at this equation here, the 2, the pi, the h is okay, the r's are not okay. So I need to find out what r is in this other equation. So I would have 100 equals pi r squared h. Okay, remember I plugged in 100 where I saw v. And then I'm trying to solve for r, isolate r. So even though pi and h are on, one's in the front and one's in the back, you can still get rid of them at the same time. Divide by pi h. Okay, so pi will simplify, h will simplify. So you've got 100 over pi h equals r squared. Okay, I can't have r squared, I've got to have just r. So again, I'm going to rewrite this line. So then in this line, I can show the square root. And make sure that the square root goes all the way down and all the way across. It should cover this whole piece, okay? So square root, same here, it should cover everything. So even though I wrote my square root like this, I could have written, and this still means, the square root of 100 over the square root of pi h. So I can take the square root of 100. The square root of 100 is 10. Okay, now the square root of pi h, it's not going to simplify to anything prettier, so I'm just going to leave it. And then of course here, you know, be very careful. That answer is absolute value of r. However, even though I need you to write this because that's mathematically true and correct, and then next step down, you're going to have, of course, plus or minus to get rid of the absolute value, plus or minus square root, plus or minus 10 over square root of pi h. Even though this is mathematically correct and you're supposed to write your work like this, of course, we're only going to use the positive answer, not the negative, because think about it, y'all. That's area, radius, height, volume. We're working with measurements, okay? So we're going to make a little note here. We're going to make a little note and we're going to say this is a measurement. R stands for radius. Okay, this is a measurement, so we will drop the minus. So your question to me is probably, oh, then do I have to show all this? Yes, you still have to show all that. Algebraically, that's correct. But since this is a measurement, we're only going to use the plus because it's not realistic to have a negative radius, okay? So that's our first note. Our second note is no need to rationalize until the very end. Can you take my word on this one? like you can, if you want, you can rationalize here, but then you're going to do all this second equation, and then you're going to have a situation sometimes where then you're going to have to do it again. So it's like, just do it the once at the end. Don't do it, you know, here on this part. So just take my word for it. I mean, I'm just trying to save you some time. Okay, so now we're going to do A of H equals, and then let me scoot this up so you can see. So 2 is acceptable, pi is acceptable, r can't have, so let's plug in. Down here for r, we've got positive 10 over square root of pi h. Okay, and then don't forget the h here because it was 2 pi r h plus 2 pi r is 10 over square root of pi h squared. Okay, so now we got a lot of cleaning up to do. So here's the deal. I can't simplify this pi and this pi because this one's in the radical. Same for the h. Okay, so I really can't do much other than 2 times 10, because remember this is all over 1 and this is over 1. So if I'm multiplying my fractions, numerators across and denominators across, 2 times 10 is 20, and so I'll have 20 pi h in the numerator. Okay, hope everybody sees that. Over, of course, this will just be square root of pi h. I'm going to leave space here. You're going to see why in a minute. And then plus, and then on this one, I'm going to drop down the 2 pi because order of operations says I need to take care of the squared here first, the exponent first. So this will become 100, because remember that squared means squared numerator and denominator. So it'll become 100 over just pi h, because whenever I square the square root of pi h, it just becomes pi h. So then, of course, I'll put this over 1 for the next step to simplify. But before I go down to the next step and simplify, since I'm getting close to the end, here's where you would want to rationalize. That's why I left this space. You know you have this radical in the denominator, so let's go ahead and rationalize here. Okay, so in the numerator, you're going to have 20 pi h square root of pi h over, of course, this is just going to become pi h, plus this is going to become 200, and then I'm sure you already saw the pi's will simplify, so 2 times 100 is 200 over, the only thing left in the denominator is h, and then here, same, the pi's simplify, the h's simplify, so final answer here, A of h equals 20 square root of pi h over nothing, over 1. So I'm not going to write it, okay, plus 200 over h.